Guys, welcome to another lecture from ecopoint, and today we will be working on the concept of linear transformations. I'll try to teach you this in a very simple language. Now, do you remember in calculus we have functions, right? So just like in calculus we have functions, here we have linear transformations. A function is a map from say R to R, okay? One-dimensional function. So for every input you have a unique output. So in vectors, with vectors, what happens is we have vector functions. So vectors function would be like, say, f is from Rn to Rm, wherein your input will be from Rn and it will generate an output, the unique output in Rm. So more often what we do is we don't use f here. More often we use t from Rn to Rm is called a vector function. This is something like, if say I have t1. T1 is a function in which the input that I'm putting is xy and the output that gets generated is say x square x plus y square. Then this becomes a vector function wherein you'll have a unique output to every input that you will put. So for example, if I put in this function the vector, say, so for example, if I put the input 1, 2, what gets generated is the vector 1, 3, 4, which is 1 square, x plus y is 3, and 2 square is 4. So that gets generated. So this is a function from R2. You had a vector in R2, that's your input, and you are generating a vector which is in R3. If you observe, this is nothing but multivariable calculus as such. So this is a part of multivariable calculus. In particular, what we are more interested in, linear vector functions. And this is what a linear vector function is, basically a linear transformation. Any function is linear or a linear transformation, you can just call it linear also. So if you ever get a question wherein a function is given from say Rn to Rm and they are asking whether this function is linear or not, these are very common kind of questions. You have to check whether it satisfies the property of linear transformation or not. So we say that a vector function, say t, from Rn to Rm is called a linear transformation or simply linear if it satisfies the two properties. Number one, this t, this function, preserves addition. So it preserves addition means that for every uv belonging to Rn, that is the set input set, we have t u plus v should be equal to tu plus tv. So that is preserving addition. And number two, t preserves scalar multiplication. So which means that for every v belonging to Rn and c, any scalar c, we have t c times V should be equal to C times TV. If you have a vector function and it satisfies these two properties, that would mean that it is a linear transformation, or in other words, that is, it's a linear function in multivariable calculus, okay? Where your input and output are some vectors, okay? Remember, I took this example T1, where T1 is from R2 to R3, and the input xy is giving us the output x square plus x square, x plus y square. So let's take two vectors here. Let's take T1 of 1, 0. That will give me 1, 1, 0. And let's take T1 of 0, 1. And that's going to give me 0, 1, 1. And let's take T1 of 1, 0 plus 0, 1. That is T1 of 1, 1. Which will give you, if you observe, you will get 1 square is 1, 2, y square is 1. So 1, 2, 1. Now, if I take T1, 1, 0 plus T1, 0, 1. If I add the values that I've got here, what are we getting? If you add these, you'll get 1 here, you will get 2 here, and you will get 1 here. Well, these two are equal. So does it mean that it's a linear transformation? Let's work on the scalar multiplication part. So let's take addition. Looks like it's happening, at least with this example. So what if I consider twice of 1, 0. So that is 2, 0, right? So let's now consider T1 of 2, 0. And that's going to be 4, 2, 0. Is this equal to 2 times of, is this equal to 2 times of T1, 1, 0, which is equal to 2 times 1, 1, 0? Well, absolutely no. That's not happening. You have 4 to 0. It's not equal to. So therefore, scalar multiplication is definitely not happening. Just with this example, we have figured it out. So therefore, T1 is not a linear transformation, or in other words, it's not a linear function, we would say. Now, the method that I used here was the method of taking an example and doing it. Okay, you can also generalize it. So for example, for the addition part, if I take up the same question, is the addition happening for all? Let's see. So if I consider two vectors, x1, y1, x2, y2. So consider t1, x1, y1 plus t1, x2, y2. Well, that will turn out to be x1 square, x1 plus y1, y1 square plus x2 square, x2 plus y2, xy2 square. Now, on the other hand, consider the sum x1 plus x2, y1 plus y2. So the output that this will generate will be x1 plus x2 whole square, twice of, not twice, x1 plus x2 plus y1 plus y2, y1 plus y2 whole square. Now, do you think the sum is equal? Absolutely no. These two things are not equal because x1 plus x2 whole square is not equal to x1 plus x2, x1 square plus x2 square. So for that example, it was happening, but in general, it will not. So many a times you will use this generalization to figure it out. Sometimes examples using 1, 0, the standard vectors will help you a lot. This is how you figure out in multidimensional world if the function is linear or not. Thank you very much.